With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So here's the question is, a body is thrown with a velocity is equal to n times the escape velocity VE. The velocity of a body at large distance away will be what? So we have to find the velocity of the body when it will throws at the initial velocity is n times of VE, escape velocity is VE. So what is the velocity of the body at large distance? Okay, so this is the initial velocity, okay, n times VE, and the potential energy at large distance will be 0. We know that because the potential energy is inversely proportional to r, where r is the distance. Okay, here we can write potential energy at large distance will be 0. This term we use further. Okay, so and when we talk about the mechanical energy, for this system the mechanical energy will be conserved. So if the mechanical energy is conserved, then we find the ratio is the kinetic energy plus the potential energy, initial potential energy, and the kinetic energy is equal to the final kinetic energy plus the final potential energy. Okay, so now let's put all the value. Okay, so here first we conclude the final potential energy of the system is 0. The potential energy at large distance will be 0. Okay, so this potential energy will be 0. Now the initial kinetic energy will be half m, and here the velocity will be, initial velocity is n times VE. Okay, here is n VE square. Okay, now the potential energy at the surface of earth will be equal to minus GMM by R. Okay, which is equal to half mv square. Here the final velocity will be v. Okay, now when we solving this equation, or first where we know that the escape velocity VE will be equal to root gm by r. Okay, where m is the mass of earth, capital M. Okay, now putting the value of VE in this equation. Okay, so here we got the equation half mn square 2 gm by r minus gmm by r is equal to half mv square. Here in this equation we just putting the value of VE. Okay, now when we simplifying this equation, or we can say taking common is gmm by r. Okay, so here we got n square minus 1 is equal to half mv square. So from this equation we cancelled m, small m. Okay, so here the value of v square will be equal to 2 times gm by r into n square minus 1. Here also we know that the value of 2 gm by r is VE. Okay, so first taking the square root. Okay, so when we're taking the square root, we got 2 gm by r into n square minus 1. Okay, so when we're putting the value of VE, when we're putting the value of 2 gm by r will be equal to, equation is VE by VE root n square minus 1. Okay, so this is our required velocity. Okay, so now let's check our options. So here option A is correct. That's it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.